The Flash, the scarlet speedster of DC. He's the fastest man in the world, but how fast can he really go? Well, canonically, Flash can run so fast that we have no ability to understand or quantify the speed he generates. Flash supposedly runs billions of times faster than light. The Flash's speed is generated by something called the Speed Force, an energy force generated by him himself and by all living things, which allows him to just sort of bypass physics. Well, comic writers can write whatever cockamamie power they want for their characters, but those of us that live in the real world have to bow to physics. It's not just a good idea, it's the law. According to the comics, the Speed Force allows the Flash to avoid friction altogether. The problem is that by bypassing friction, that means he's also bypassing traction too. If the Speed Force negates friction, Flash would appear as just a torso hovering over a red blur of legs, like a Roadrunner cartoon, but not actually moving at all. If we apply real-world physics, Flash absolutely cannot travel faster than light. For pretty much any object traveling less than light speed, that is to say anything with mass, to reach light speed itself would require basically infinite energy, which is impossible. And even though it is theoretically possible to go faster than light via a light boom, which is super cool by the way, if you do manage to go faster than light, it will take an infinite amount of energy to slow down again. Turns out, faster than light travel would have the same difficulty going sublight speed as sublight things have going super light speed. Not that Flash would ever get that fast anyway. See, in the real world, it's not actually possible for objects with mass to even approach the speed of light, because if you touch anything, you would instantly explode into energy. Even in the vacuum of space, you can expect to encounter, on average, 1 atom of material per cubic centimeter out in the void. If Barry touches anything going that fast, he would instantly convert to 7,949,535,565,674 megajoules of energy, which is exactly what happens when Barry Allen's 195 pounds of mass are fed into Einstein's E=mc² equation. For reference, that would create an explosion 38 times greater than the Tsar Bomba, which is the biggest nuclear blast ever detonated. Not that it matters, though, because if Flash was traveling at Mach 10, or 10 times the speed of sound, he would push a plug of air in front of him. Because of abatic compression, the air wouldn't be able to get out of his way fast enough, and would heat up and then eventually convert into plasma, around 752 degrees Fahrenheit. Running at this speed would pull the air behind a Flash at 6,311 miles per hour, which would not only cause the Flash to incinerate himself like a meteor entering the atmosphere, and would also cause winds 2,000 times faster than a Category 5 hurricane. Even running at 761 miles per hour, the speed of sound at sea level, would shatter windows, burst eardrums, and have enough overpressure to turn internal organs into jelly, just from him passing by. The fastest any human has ever gone without protection was when John Paul Stapp attached himself to a rocket sled and was propelled at 632 miles per hour in 1961. He experienced 40 Gs, or 40 times Earth's normal gravity, which proved that humans can take a lot of acceleration force, at least for a short while. But it should be noted that even a sustained G-force of just 5 to 8 Gs is sufficient to black out and eventually kill pretty much everyone. But Stapp was on a rocket sled. The Flash would be running by foot, and at the speeds generated, his bones would shatter like eggshells. It takes about 4,000 newtons of force to break a human femur, which is the most robust bone in the human body. Running at those speeds, Flash would generate much more force than that. Not to mention the absolute destruction of his delicate foot and toe bones, which only require 24 pounds of pressure to break. You're not running with no feet or legs. Traveling at subsonic speeds, things don't get much easier. When Flash runs, he's going to run into problems with wind resistance. That is to say that the wind will slow him down. Normally, terminal velocity for humans is about 120 miles per hour. 150 to 180 if they're in a streamlined dive, going head first. Beyond that, the effect of the wind would be like a shock wave, a wall of air that Barry would hit with tremendous force. At speeds of 502 miles per hour, a shock wave would be sufficient to shatter concrete, and with wind speeds of only 294 miles per hour, it's generally fatal to humans. At more than terminal velocity wind speeds, Flash wouldn't even be able to stay upright, let alone run. So for a superhero like Flash, top speed must necessarily be less than terminal velocity. But that is still wicked fast. For us mere mortals, that is way faster than anything any normal human would ever be capable of. Usain Bolt, the fastest man in the world IRL, has achieved a top speed of 27.8 miles per hour in the 100-yard dash. This is very close to the theoretical maximum speed that humans have in general. Running requires muscle contraction to be able to push off the ground with each step and accelerate yourself forward. And the maximum muscle contraction speed for a human is only 35 to 40 miles per hour. So therefore, theoretically, the top speed of a human sprinter is only 31 miles per hour, and Bolt is not very far off from that. But the Flash is so incredible that he would be 4 times faster than Usain Bolt at 120 miles an hour, meaning that he would be able to cover the 100-yard dash in a little less than a second, which is pretty impressive no matter how you slice it. In fact, if you were standing still and the Flash ran past you, you wouldn't even be able to see him go by. He would be traveling at the speed of a major league fastball, faster than the eye can track. He would simply be there 1 second and gone the next. He may not be going at ludicrous speeds, but he would still have no trouble being the fastest man alive. And if we want to even try to catch a glimpse of the Scarlet Speedster, we would need to keep our eyes and mind open and always be creative. Thanks for watching.